Hi everyone, and welcome back to part 3 of our polynomials and graphing rational functions. So in this one we are going to actually start graphing some rational functions. We kind of have all the pieces that we need now, so we're going to put them all together and throw it on a graph. So for each of these, we're going to be finding the vertical asymptotes, horizontal asymptotes, x-intercepts, and the y-intercept. And we're going to use all of those things to graph the function. So let's get started. First off is going to be the vertical asymptote. So for this one, we set the bottom, which is x plus 4, equal to 0, and solve. In this case, x equals negative 4 will be our vertical asymptote. So I'm going to go ahead and start by placing our vertical asymptote as a dotted line on our graph. Next up, our horizontal asymptote. The degree on top is 0. The degree on bottom is 1. So the degree on bottom is bigger, which means y equals 0 is automatically going to be our horizontal asymptote. So we are going to also put that on our graph like so. Okay, next one. We need the x-intercepts. Remember, that's where y equals 0, or it's just setting the top equal to 0. Well, in this case, if we set the top equal to 0, that's 1 equals 0. That isn't true, which means there's just no x-intercepts. All right, let's look for y-intercepts. For y-intercepts, we are going to set x equal to 0. It's going to be 1 over 0 plus 4, which is going to be 1/4. So 0 1/4 is going to be our y-intercept. So really close to that line right there. Okay, so these are just going to be some sketches of rational functions. So we're not going to go crazy by trying to get too accurate, but we do want to get a basic idea. And remember from our first one that it's going to start hugging those asymptotes. It's going to get really, really close to both the vertical and horizontal asymptote. So to graph it, we are just going to hug the asymptote, come through our point, and then hug this one. And that gets us a good idea of what that side is going to look like. Now, there's a problem right now, though. What about this section? We have no idea what's going to go there. So we are just going to need one more point. We're going to plug in any x value from this region over here. -5 is a nice one, and it's one of the smaller nice ones. So I'm going to choose that one, but you could choose any x value that's smaller than -4. So if we plug in -5, so this is going to be our extra point. If we plug in -5, we're going to get 1 over -1, or just -1. So -5, -1 is going to be another point, and all that lets us know is which side it's going to be hugging the asymptote from. We now know it can't be up here because, well, we can't somehow come down and grab this point that we now know is on it. Instead, it's still going to be hugging the asymptotes, but it's going to be on the bottom. And that's it. That's our basic sketch of this rational function. All right, number 2. So again, we're going to be looking for those same four things. So starting with vertical asymptote. For the vertical asymptote, we're going to set the bottom equal to 0. And we get x equals 3. So that's our vertical asymptote. Put that on there. Then we can move on to our horizontal asymptote. In this case, the degree on top is 1. The degree on bottom is 1. So this is the one where we look at our two leading terms and we look at the coefficients on each. In this case, they're both just 1, so it'd be 1 over 1, which is 1. So y equals 1 is our horizontal asymptote. Again, we can go ahead and put that on there as well. Next, our x-intercept, which is where y equals 0, or just put the top equal to 0. So x minus 6 equals 0, which means x equals 6. So 6, 0 is going to be our x-intercept, which is going to be right there. For y-intercept, that's where x equals 0. So if we plug in 0 for each, that's going to get us negative 6 over negative 3, or 2. So 0, 2 is our y-intercept. Now, luckily, we already have a point that is on each of the different sides of that vertical asymptote, so we're not even going to need an extra point on this one, because we already know from which direction it's going to be hugging those asymptotes. So we just hug the asymptote, go through our point, hug the other asymptote, and we are good to go. We do that for both points. All right, last one. This one's a little bit more difficult because it does have a quadratic on bottom, but that's no big deal. We can still get through it pretty easily. So starting out with the vertical asymptote. So we set the bottom equal to 0. And in this case, we're actually going to have to solve for x by either factoring, or using the quadratic formula, or using the square root property. Whatever's best for you. We've been factoring a lot already in this one, so I'm going to go ahead and do it by factoring. So we can first take out a 2. So we'd have 2 times x squared minus 9. And then this part right here is difference of squares. So it's going to be x plus 3, x minus 3. And then we can just set both of these equal to 0, getting x equals negative 3 and x equals 3. So we have two different x-intercepts, negative 3, 0, and 3, 0. Sorry, not x-intercepts, vertical asymptotes at x equals negative 3 and x equals 3. So let's go ahead and put those on our graph. So x equals negative 3, x equals 3. And then let's move on to our horizontal asymptote. Our degree on the top is 2. Our degree on the bottom is 2. So in this case, the degrees match. So we're going to look at those leading terms. For the leading terms, we have a 3 on top and a 2 on the bottom. So 3 halves. So y equals 3 halves is going to be our horizontal asymptote. So that's 1.5, so right in between 1 and 2 is going to be our horizontal asymptote. Might not be the best representation of the middle of those two, but again, these are just sketches, so don't worry if it's not exactly in the middle. Mine definitely isn't. All right, next up is going to be the x-intercepts now. So that's where y equals 0, or just set the top equal to 0. So we got 3x squared equals 0. In this case, it's nice and easy because if we divide by 3, we got x squared equals 0 still. And then if we square root both sides, we don't actually need the plus or minus because, well, plus or minus 0 is still just 0. So we just get x equals 0. So 0, 0 is our x-intercept. And then for our y-intercept. For our y-intercept, we're going to set x equal to 0. So we got 3 times 0 squared over 2 times 0 squared minus 18, which is going to be 0 over negative 18, or just 0. So again, 0, 0, that's the y-intercept. Okay, so we do know one portion of this graph. Again, this is going to hug our asymptotes, so it's going to end up going something like this, because we can't just cross up here. Now, for horizontal asymptotes, you can actually cross them sometimes. However, for this class, we're not going to actually get into that part of it. So for this one, we can just hug the asymptotes that are on the bottom because we know our point is on the bottom. However, there are two sections where we still don't know what's going on. So we're going to need to grab a point from each of those sections. So extra points. I'm going to pick x equals negative 4 to get something from that left section. I'm going to pick x equals positive 4 to get something from the right section. And we're just going to plug both of those into the function. So 3 times negative 4 squared over 2 times negative 4 squared minus 18. It's going to be 3 times 16 over 2 times 16 minus 18, which is going to be 48 over 32 minus 18. That's 14. Which is going to be approximately, if you just plug this into your calculator, 3.4. So we have negative 4, 3.4 as another point. Now, that's not the prettiest point ever, but remember, we just need to get it approximate. That way we can see what side of this horizontal asymptote it's actually on. So if we go to negative 4 and go up about 3.5, it would be about right here. Which means it's going to be in this upper part. Perfect. Let's go and do the same exact thing with 4. So we have 3 times 4 squared over 2 times 4 squared minus 18, which, if you notice, is going to end up working out the exact same way. So we're going to have 48 over 14, which is about 3.4. So we're also going to have 4 comma 3.4. Right about here. Hug our asymptotes. And we are done. So that was just a few examples just to get some basics for graphing some of these rational functions. You can definitely get a lot deeper into it, but for this class, we're just interested in these basic sketches like this. All right, with that said, that is all for these notes. So thank you for watching.